and I will be talking about matching markets. How do markets emerge, and how do you put prices for products in the markets? And this is taken from the book Networks, Crowds and Markets by David Easley and John Kleinberg. It was written in, I think there's a mistake here, in 2013. A very good book, and many of the things for the course I have taken from the book, and I encourage you to read it and familiarize yourself with it. Some of the things are relatively difficult to understand, and I will try to explain to you the concept of matching markets. Imagine there are 5 persons like there are here, and you are traveling somewhere and you have 5 rooms. How do you deal or distribute these rooms with these 5 persons? Well, you ask them where they want to go to, and what you get here is a list. Alexei would like to go to room 1, 2 or 3. Kalle would like to go to room 1. Tytti would like to go to room 2. Maya is rather flexible, 2, 3, 4 or 5, they're all okay. Now, does a matching market exist? Can you distribute these rooms in such a way that everyone will get a room which was on his or her wish list? Well, if you look at the picture on the right, yes, you can do this, and it has been done on the picture, and you can confirm that everybody gets a room which was on their wish list. Now, simple, right? Not so. By just removing Alex's from his wish list, room number 3, you end up with a situation which has been identified on the right, and this is known as a constricted set. It basically means that when you look at the whole picture, there are 3 persons, Alexei, Kalle and Tytti, and when you look at their wish list, there are only 2 rooms on all of their wish lists. They are either room 1 or room 2, and there is no way you can give these rooms to 3 people. There are only 2 rooms, but there are 3 persons. This is a constricted set. So this is an opportunity to start working with money and to start to see how people would be paying, if you like, extra for this room, for these rooms, how a market would emerge. The first question is, how much do these persons value the room? So you can add into the discussion, and here I have changed the names, and I'm following the book here, and there are 3 persons, 3 rooms, and you look at how much each person values. So the Xin, the X here, values room 1 at 12, room 2, room B at 4, and the third room C or room 1 at 2. And then you can look at keeping these valuations in mind. Is there a optimal assignment? And yes, you can give room 1 to X, room 3 to Y, and room 2 to Zeta. However, it is not only a question of how much these people value the rooms, but it is also a question of what their profit is. So they could start creating and dealing these rooms with each other. So X values the room at 12, if you look at the picture on the right, and the B room at 4, and the C room at 2. However, he might be getting a profit if he were to sell the X room further. So, for example, if he buys A for 4, so he spends $4 or euros for it, and his value for that room, how much he values himself, is 12, then in a way his profit is 8. And now what we are doing is we're optimizing for the profit. And if you look at some asking prices, here I have put, just some random prices. The price of A is 5, the price of B is 2, and the price of C is 0. Now let's look at the profit. So X values A, look at on the top right. Let's see if I can get my pen here and move. So I'm talking about these here. If X will buy A and the price of A is 5 and he values it at 12, which is here, then his profit is 7. And then we can calculate the same here, or we could actually count it for all the others. So if he wants to buy B, his valuation for B is 4, the price for B is 2, so 4 minus 2 is 2, and then the price for C, his valuation is 2, and then the price is 0, so his profit would be 7 for room A, 2 for room B, and 0 for room C. There is a mistake here, sorry for that.